In this video, we will evaluate some simple logarithmic expressions. So let's start by reviewing what the expression log base b of y represents. So this expression log base b of y represents the exponent on a base of b needed to produce a result of y. So if we have b raised to some exponent and it gives us a result of y, then this expression up here, this logarithmic expression, represents that value. So let's put this to work in some numerical examples. Consider the expression log base 3 of 9. This expression represents the exponent on a base of 3 needed to produce a result of 9. So if we think about that, if we have 3 raised to an exponent and it gives us a result of 9, then that exponent is represented by log base 3 of 9. If you think about that a little bit, you should notice that 3 squared equals 9, and therefore the exponent on a base of 3 needed to produce a result of 9 is 2. So 2 is that exponent, and therefore we could say that log base 3 of 9 is equal to 2, because 2 is the exponent on a base of 3 needed to produce a result of 9. Now this might seem kind of scary, or there's a lot of things going on here, but just remember that this whole logarithmic expression represents an exponent. The base of the logarithm is the base of the exponential expression. Let's look at another expression. Consider the expression log base 3 of 1 divided by 27. This means that if we have a base of 3 raised to some exponent and it gives us a value of 1 over 27, then this logarithmic expression represents that value. So 3 to what exponent gives us a value of 1/27th? So 3 cubed gives us 27, and therefore 3 to the negative 3 should give us 1 divided by 27. And therefore negative 3 is the exponent on a base of 3 needed to produce a result of 1/27th, which is exactly what that logarithmic expression represents. So we would say log base 3 of 1/27th has a value of negative 3. Let's look at one last example. Consider the expression log base 5 of 1. So this represents the exponent on a base of 5. So we have 5 raised to some exponent, and we know that that power is equal to 1. Then that logarithmic expression represents that exponent. So 5 to what power gives us a value of 1. Remember that any positive number raised to a power of 0 gives us 1, and therefore 0 is this exponent right here. And therefore log base 5 of 1 is equal to 0.